In this section of notes, we're going to return to the idea of significance testing. So in the previous notes, we kind of got an idea of what it was, but we haven't actually looked at how you go about doing a significance test. So we're going to return to our example with the basketball player who says that they make 80% of their free throws, but then when they did a 50-shot trial for us, they only made 32. So they only made 64% of their shots. And we want to know, is that enough evidence to suggest evidence against their claim? So you'll remember we came up with these hypotheses in the last section where we said P is going to be the true proportion of shots that this basketball player makes. The null is that it's equal to 80 because that's what they said it was. And then our evidence suggests that maybe it's a little bit less because 64 is less than 80%. So that's how we set up our hypotheses. Now, next we have to use some conditions because we're going to calculate some probabilities. And these are the same conditions that we've been using for quite some time. These are the same conditions that we used in sampling distributions and the same conditions that we used in confidence intervals. So first, we want to make sure that our sample was randomly selected, or if we're doing an experiment, we want to make sure that we're randomly assigning our participants to the treatments. If it is a sample, we either want the sample to be happening with replacement, or if it's happening without replacement, then we want our sample size to be less than 1/10 of the population size. And we are hoping that our distribution ends up being approximately normal so that we can use our normal probability calculations, either our table A with the z-scores or our calculator with the normal CDF. So this is where we do our n times p and n times 1 minus p. Note here it says p sub 0 because we're using our null hypothesis value, not our sample value. So in this example, we'd be using the 0.8 rather than the 0.64. Now, in terms of our distribution, you'll recognize these formulas for mean and standard deviation from, again, sampling distributions and confidence intervals. So these are on your formula sheet. You don't need to memorize them, but they should look familiar to you. And then remember that our sample gave 64%, and you can see that's pretty low there. That's way in the tail. And what we'll use is some of our calculation abilities to figure out what are the chances of that. Now, since we're going to be talking about probabilities and calculating those percentages, that hints at using a z-score. So we are still going to use a z-score, and this formula, again, is on your formula sheet where we have our test statistic equal to our statistic minus our parameter divided by the standard deviation of the statistic. That's essentially the same as like a z-score from earlier. Our statistic is just going to be what we got in our sample. The parameter is what we thought it was, so that's our null value, and then we just had that formula to get our standard deviation of the statistic. So in this case, when we go to plug in our numbers, the 64% was the statistic, the 80% was our parameter, and then when we use that formula with the p times 1 minus p divided by n, that is where we're getting the 0.0566 for our standard deviation of the statistic. So we get our z-score of negative 2.83. And it's so hard to see here, it's just barely even shaded. But we can either use table A to get the probability of this happening, or we could also use our calculator. So if we were going to use our calculator, that's where we would use our normal CDF. Don't forget, you must still draw a picture and you must label the lower, upper, mean, and standard deviation if you're going to be using your calculator instead of using table A. But you're going to get the same result either way. You're going to get the same p-value. And again, that matches with our simulation that we did in a previous section where we got such a very small number. It's not the same number, obviously, because a simulation is not the same thing as a theoretical calculation, but it's very close. It's still a very small number. So we see that it's very unlikely to get results like this, assuming that the null hypothesis was true. Now, before moving on to the practice problems, there's going to be a second video on using your calculator in another way than using this normal CDF. There's even something more straightforward where you can just put the initial information into your calculator. Make sure you watch that video and then come back and try the practice problems before moving on to the next section of notes.